Hi everyone. In this video we're going to talk about the product and quotient rules for logarithms. So what that means is we're going to see how we can rewrite a logarithm of a product. So if I'm multiplying two terms together inside of a logarithm, like I am here, so I have log base b of u times w, I can rewrite that as a sum or as addition. And if I have a logarithm of a quotient or a division inside here, so I have log base b of u divided by w, I can rewrite that as a difference. And so this is what we call the product and quotient rules for logarithms. Now, one of the most common applications we're going to see is we're going to start over here. We're going to see something that looks like the right-hand side of one of these, where I have two logarithms that are being added together. So say if I have two logarithms like this that are being added together, what I can do is simplify an expression like this by taking two logarithms and making them one. So anytime I'm adding two logarithms together, I can replace that with one logarithm of a product on the inside. And if I'm ever subtracting logarithms, like here, I have two logarithms that I'm subtracting, I can rewrite them as one single logarithm where I take my inputs and I divide them. So for this video, we're going to work through several examples of these rules. So what I'm going to do is I'm going to clean this up, I'll come back, and we'll see an example of a question we can answer using these rules for logarithms. Okay, so I've cleaned everything up and we're back here with a quick example. So if I look at this, I have two logarithms. I have log base 10 of 7 over 3 plus log base 10 of 300 over 7. And what I want to do is combine these two together using one of the rules above. So if I look above, if I look at the rule in blue, you'll see that that's when you're subtracting two logarithms. So I must be using this rule on the left in the black text. We're adding two logarithms together, and so what I'm going to do is see if I can take these and somehow rewrite them as one logarithm. Well, what we'll notice here is I have a log base b and a log base b, and those two logarithms are right here. So in this example, I have a log base 10 and another log base 10, and what I'm going to do is take these two, and I know that my answer is going to be log base 10 of something. Okay, so something will go there on the inside. And what I have to do is come above and identify, well, one of them I have an input that I'm going to call u, and the other one I have an input that I called w. So down here, my input, I'll call this one u, and I'll call this one w. So I have an input here. U is 7/3, and w is 300 divided by 7. And so inside of my single logarithm, it looks like I put u times w. So I'm going to come over here, and I'm going to take this, and inside of here I should have u times w. So let's go ahead and write this down. My u is 7 over 3 times my w, which is 300 over 7. Okay, and so the way I picked this problem, some nice things really happen here, because when I'm multiplying 7 over 3 times 300 over 7, a lot of stuff is going to cancel. So if I look at this, I have a 7 here in the numerator and a 7 in the denominator. Those will end up canceling. And then I have 300 divided by 3, and that turns out to be 100. So all of this simplifies down to be log base 10. Well, 300 over 3 is 100, so log base 10 of 100. All right, so if I think about this for a second, the logarithm is a question. It's asking me 10 to what exponent is going to give me back 100. So 10 to what power gives you back 100. And if I think about that for a second, 10 to the first power is 10, and 10 squared, or 10 to the second power, is 100. And so the answer to this question is going to be 2. So all of this simplified down to be 2. So log base 10 of 7/3 plus log base 10 of 300 over 7 is 2. Okay, and so this is an example of how we can use the product rule for logarithms. So I'm going to clean this up, and we'll be back and we'll see how we can use the quotient rule for logarithms. All right, so we're back here with some logarithms in front of us that we may want to clean up. And as I look at this problem, let's read it out here. I have log base 3 of 39 over 2 minus log base 3 of 13 divided by 2. And so I'm wondering, can I figure out what kind of number this is? Does this simplify down to be a more familiar number? And can I maybe get rid of these logarithms? So with that in mind, when I look at this, there's sort of two paths forward that I could take. I could look over here at my rule for logarithms, and I could see that I have a quotient right here, and I have a quotient right here. So I could be thinking that I want to take this part of my rule, and I want to break it up as a subtraction problem. So I could write this as a subtraction, and I could write this as a subtraction. But the way that I want to think about this is I actually want to make there be less logarithms. So I want there to be less logarithms so I can simplify my work. And what I'm going to do here is I'm going to notice that I have a log base 3 and a log base 3, and I'm subtracting them. So really what I have is I'm starting over here on this right side of my equation, and I want to go over back here to the left side of my equation. So the rule tells me what I can do is I can rewrite this as log base 3 of something, right? Some quotient. So what I have to do is I have to go through and identify what's my u and what's my w. Well, my u over here, right, that's my first term, that's my 39 over 2. And the 13 over 2, this is my w. So I'm going to have, in here, I'm going to have a u on top, and I'm going to have my w on the bottom. And so what that says to me is, okay, in the numerator over here, I'm going to have 39 divided by 2. In the denominator, I'm going to have 13 divided by 2. Okay. So I picked this problem in particular because what it gives us is, over here we have a fraction. We actually have two fractions inside of another fraction. And oftentimes this is very hard for us to deal with. So when I see a fraction inside of a fraction, I always think about the phrase dividing is the same as multiplying by the reciprocal. So really what I'm doing is I'm taking 39 over 2 and I'm dividing by 13 over 2. So this inside, I'm taking 39 over 2 and I'm dividing by 13 over 2. But instead, what I'm going to do is I'm going to take 39 over 2. So let's put it in a different color here. I'm going to take 39 over 2, and instead of dividing by 13 over 2, I multiply by the reciprocal of, which is 2 over 13. So this 39 over 2 times 2 over 13 is the same as what's going on in the inside here. Now, if I clean this up, if I look at this fraction, I like this. I like looking at this a lot more than I like looking at this fraction up here, because it seems like nice things are going to happen. I'm going to get some stuff that cancels out, like this. So the 2 in the numerator and the denominator, those cancel out. And if I think about 39 divided by 13, 13, 26, 39, it looks like 13 goes into 39 3 times, and so this ends up becoming 3. So just by dealing with my fractions and thinking to myself, dividing is the same as multiplying by the reciprocal, what this becomes is log base 3 of 39 over 2 times 2 over 13, which is the same as log base 3 of 3. Okay, so by thinking about it this way, by breaking everything into one logarithm, right, bringing everything together, a lot of nice things happen and they simplify for me. And so I'm going to ask myself, log base 3 of 3, well, what is that? 3 to what exponent would give me back 3? And the answer to that question is 1. Right, so all of this work, I was able to simplify my original expression. Okay, so I was able to simplify this expression here, and it's just the number 1. Great. All right, so I'm going to clean this up. We'll be back with one more example where we put the two rules together. Okay, so we are back. We have an example, and my goal here is to clean this up and see if I can make this a nicer number. It's just sort of a nicer number in disguise. So if you want, this would be a good place for you to pause the video and try to do it yourself, and then we'll come back and do it together. Okay, so the first thing that I'm going to do here is I'm going to look at the structure of my expression, and I notice that I have these parentheses right here. So I have this big parenthesis and this big parenthesis, which is telling me that maybe I should look at what's going on the inside of this first. And so what I'll notice first is that I have something going here. I have log base 5 of 2/5 plus log base 5 of 11 over 5. And so that looks like this form over here. So if I want to bring these two terms together, what I can do is identify my inputs and then multiply them together to create one logarithm. So let's go ahead and do that. So log base 5 of 22, I haven't done anything with that, but this over here is going to be log base 5 of, okay, so I'm going to have a 2/5 times an 11/5. Right, so I took my 2/5 over here on the left and brought it down, and it's 11/5. They both went inside the same logarithm, and they're being multiplied together. Okay, so let's think about this. 2 times 11, that's 22, and 5 times 5, that's 25. So what I can do is I can clean this up a little bit. 2 times 11, we said that was 22, and 5 times 11 is 25. So this whole thing, as I erase it, it will become 22 divided by 25. Okay, so log base 5 of 22 divided by 25. All right, so step 2, when I look at this, I have now a subtraction. I'm subtracting two logarithms with the same base. So I'm going to use my rule for quotients. I can rewrite this subtraction as a quotient. So here we go. This is log base 5 of, well, 22 is going to go in my numerator, right, because that's out front. And then in my denominator, I'm going to have 22 divided by 25. 22 divided by 25. Okay, so again, I have one of these things where I have a fraction inside of a fraction. So, what's my way out of this? Well, if I remember, dividing is the same as multiplying by the reciprocal. So inside of my logarithm, this is 22. Well, it's not divided by 22 over 25. It could be times 25 over 22. Okay, so that looks a lot better to me. I like that a whole lot more because it looks like this 22 in my numerator and this 22 in my denominator, they cancel out. And so what I'm left with is log base 5 of 25. Okay, so this is exciting to me because I know that 25 is a power of 5. So 5 squared, or 5 to the second power, is 25. And so what that tells me is that this answer to this question is 2. So 5 squared is 25. So all of this work above, if we know a little bit about the product and quotient rule for logarithms, we can clean all of this up and get it just to be the answer of 2. All right, so I hope these videos helped out, and I'll see you next time.